Let's solve the absolute value inequality. Step 1 is to make sure that the bars are isolated, and in this case they are. Notice the absolute value bars are by themselves. Next, you want to look at the direction of the inequality and then the sign of the number on the right, the constant. We have greater than a positive value. Whenever we have greater than a constant, then we split this into two separate inequalities. The first inequality, we're going to basically copy the entire problem but drop the bars. So we have 2x plus 1 is greater than or equal to positive 5. The other inequality, we're going to copy the inside of the bars, but then we will change the direction of the inequality and change the sign of the constant. Less than or equal to negative 5. From here, we can solve these separately. The inequality on the left, we will subtract 1. 2x is greater than 4. And then divide by 2. X is greater than or equal to 2. The inequality on the right, we will again subtract 1. 2x is less than or equal to negative 6. And then divide by 2. X is less than or equal to negative 3. Now the directions in this case say we need to use interval notation, but sometimes it's helpful to draw a graph first and then get the interval notation. So thinking about a number line, we have x is greater than or equal to 2 and x is less than or equal to negative 3. This one's going to come first. So we have negative 3 and everything less than negative 3, but we can actually include negative 3 due to the equality. And then we have a gap, and then positive 2 to forever. As an interval, we have two separate intervals. First, we have negative infinity to negative 3 with a bracket. Then we'll union that, we'll join it with bracket 2 to positive infinity. Up next, we first need to isolate the absolute value bars. We can do that by adding 4 to both sides. After you isolate the bars, look at the direction of the symbol and then make sure that this number is a positive value. When it is less than a positive value, then we create a compound inequality. First, we'll copy what we have, but drop the bars. And then on the right side, you want to keep the same symbol, the less than symbol, and we'll change the sign of this number and put it over here to make it negative 3. And now we solve the compound inequality. Subtract 1 first, and then we need to divide everything by negative 2. Remember, when you divide by a negative, this will change the direction of the inequality. So we have 2 is greater than x is greater than negative 1. Next, we'll reorder this so that the numbers that are smaller are on the left. So we have negative 1 is less than x is less than 2. Again, if we want, we can graph this to help us see the interval a little better. We're going from negative 1 to positive 2. Open circles because we don't include the values on the ends. And then the interval, we have negative 1 to positive 2 with parentheses. In our next example, we first need to isolate the bars. To do that, we can add 5 to both sides. Once you isolate the bars, look at the direction of the inequality and also make sure that this is a positive value. Since we have greater than a positive, this is going to split into two separate inequalities. The first one will copy basically everything except for the bars. Then the second one, we copy the inside, change the direction of the original inequality, and then change the sign of your constant. And now we solve these separately. Up first, the inequality on the left will subtract 3, and then divide by -1. Remember to change the direction of the inequality. The inequality on the right, we will subtract 3, and then divide by -1. Again, that changes the direction of the inequality. Let's use a graph. We have everything that is less than or equal to -4, and everything that is equal to or greater than 10. For the interval, we have two sets, -infinity to -4 for bracket, union, bracket 10 to positive infinity. In our next example, we need to first isolate the absolute value bars. To do that, we can subtract 3 on both sides. After you subtract to isolate the bars, notice the direction of the symbol and the constant. This time we have a negative constant. We haven't seen that up to this point. If the constant is ever negative when you're dealing with an inequality with absolute value, you'll have one of two special situations. Either it's going to have an infinite number of answers or there's no solution. Think about what it means to be absolute value. This is a positive number. We don't know what its actual value is, but we know that whatever is on the left, whatever it is, we know it's positive. How many positive values are less than -1? None of them. You can't have a positive something that is less than a -1. So the answer here is simply no solution. This is a very similar example. We need to first isolate the bars by subtracting 3. After you isolate the bars, look at the direction of the symbol and look at the constant. This time the constant is negative. As I said earlier, if you ever have an absolute value inequality and your constant is negative, it's one of two special situations. The left side is a positive value due to the absolute value. So we have a positive thing that is greater than -1. How many positive things are bigger than a -1? All of them. So here, the answer is all real numbers, or negative to positive infinity.